Question 21. Regular polygon with 5, 6, 7, and 8 sides are inscribed in the same circle. No two of the polygons share a vertex. No three of their sides intersect at a common point. At how many points inside the circle do two of these sides intersect? All right, so let's draw a diagram. Right, so you can see here, so we have a circle. We put a regular hexagon here. So this blue is a pentagon, right? So then we can draw a hexagon. Go from here to draw here to here, here, and here, maybe here. So you can see here. So they're gonna be intersect 10 points. So you can see these gonna cross this side, right? We have 2 points. These have 2, these have 2, these have 2. So this only configuration can for. So you can see 5 and 6 give us 10 points, right? Similarly, you do 5, 7, you're gonna do the 10 points. 5 and 8, you're gonna have 10 points, right? If you look at 6 with 7 give us 12, 6 and 8 give us 12, and eventually we have 7 and 8 give us 14 intersecting points. So added together, we got E68. Question number 22. For each integer n greater or equal to 2, let Sn be the sum of all product jk, where j and k are integers and 1 smaller or equal to j, smaller than k, smaller than or equal to n. What is sum of the 10 least value of n such that Sn is divisible by 3? Okay, so this is about the sequence and series, right? We call Sn be the sum of all product jk. So we can write this in the summation notation. Summation of jk, so where k is greater than j, all the way to, so I think it should be n minus 1, right? N minus 1. Okay, so then we're going to do j times k, the product of j times k. Right. All right, so then what does this mean, right? So we're going to just explore this first. What is this, right? So first one, we can think about, so we can see that start from 1. So let j equal to 1, so k must be greater than 1. So 1 times 2, then plus 1 times 3, plus 1 times 4, then all the way to 1 times n, right? So if we let j equal to 2, then 2 times 3, right? K equal to 3, right? And also we can have k times k equal to 4, 2 times 4, then 2 times 5, all the way to 2 times n, right? So continue, we have 3, j equal to 3, we can do times 4, then all the way to n, right? Of course, the last one going to be n minus 1, bj times k is to equal to n, right? So this is this means, right? So we can write this summation like this, right? So we can let this equal to 1 times parentheses here, we have 2 plus 3 all the way to n. The second line gives us 2 times 3 plus 4 plus 5 all the way to n, and so on. All right, so actually we can write all this in a summation like this, with summation j from 1 to n minus 1. So that's represented this one to all the way here. So inside we have j times j plus 1 plus j plus 2, j all the way to k, right? Each of these. All right, so I think this is going to be the summation notation for Sn. Sn equal to summation of j of these, right? So this one actually we can just simplify a little bit. So this actually is arithmetic sequence. So this part can write j plus 1 plus n divided by 2. Then times number of numbers, right? This actually is average. That's going to be n minus j. Okay, so I think I'm going to just substitute here. We find that Sn equal to summation j equal to 1 to n minus 1. Then we have j times a half. Here we have n plus j plus 1 times n minus j. Okay, so I'm going to continue to simplify this a little bit. So this equal to summation j equal to 1 to n minus 1. So I put the 1/2 in the top, right? 1/2 in front. So we have j times. So this is going to be n squared. We distribute times plus nj plus n minus jn minus j squared minus j. So continue simplified. This summation 1/2 j equal to 1 to n minus 1. So this is going to be, yeah, you can see this is cancelled, right? Cancelled. We have this equal to j times n squared plus n minus j cubed, j squared minus j. So continue simplifying. So I'm going to write 1/2 in the front. So here we have summation j equal to 1 and minus 1. So we're going to distribute. The first one we have n squared plus n times j. Then we're going to minus summation j equal to 1 and minus 1. So this is going to be j cubed. Then we're going to minus summation j equal to 1 to n minus 1. Then j squared. So let me clean this, make more space. All right, so now we just need to simplify this. We have this summation, and this summation, right? So I just point out this part, this n squared plus n is just constant, right? So we can just bring this to the front. So this is going to be 1/2. So that's going to be n squared plus n summation j equal to 1 to n minus 1. So this j. So minus summation j equal to 1 to n minus 1. Then we have j cubed minus summation j equal to 1 to n minus 1. Then we have j squared. So now basically we have three basic summation formulas, right? We have these, we have these, we have these. So I'm going to write these as three basic formula, right? So if you, so that's the first one, summation of j equal to 1 to n minus 1. Then j, basically that's going to be 1 plus 2 plus 3 plus all the way to n minus 1. So this is basically equal to n times n minus 1 over 2. So summation of j equal to 1 to n minus 1, j cube equal to 1 cube plus 2 cube plus 3 cube all the way to j minus 1 cube, right? Oh, so n minus 1 cube, sorry. So this actually equal to, right? So if you learn the sum of cube, this actually equal to half of n times n minus 1, then everything squared. Okay, so last one, we have summation j equal to 1, n minus 1, so that's j squared. So which equal to 1 squared plus 2 squared plus all the way to n minus 1 squared. Right. So this one actually equal to, we know the formula, that's going to be n times n minus 1 times 2n minus 1 over 6. Right, so I think we just need to plug in here. We simplify these expressions. Right, so once we plug in this is gonna be 1/2. So that's gonna be n squared plus n times half of n times n minus 1. So minus half of n times n minus 1 squared. So minus summation. So this actually is 6 n times n minus 1 over 2n minus 1. Right, so we can put them on the same denominator. So that's going to be 1/2. So this is going to be times, this is going to be 1/12, right? Okay, so top one, we're going to factor, if we have n and n minus 1. We factor n and n minus 1. So inside we have, this is going to be, we're going to have 6, the first part here. So give us 6 n plus 1 so n squared times n. So we're gonna have here, so that's gonna be 3 n times n minus 1. Then we're gonna have here, so that's gonna be minus 2n 2 of 2n minus 1. So after simplification, we got 24. So we have n times n minus 1. Inside, we have 3n squared plus 5n plus 2. So which continue equal to n times n minus 1 times n plus 1 times 3n plus 2 over 24. All right, so this basically is the simplification. All right, let me clean the board. So we're gonna just write on the top. Okay, so question number 2. So we got the Sn actually has this general formula: n times n minus 1 times n plus 1 times 3n plus 2 over 24. So the question is, what is sum of all the 10 least value of n such that Sn is divisible by 3? So we want Sn divided by 3 and find at least 10 values. We're gonna find the sum of this, right? So we want Sn divisible by 3. So these 3 divides this, right? So we can see here. So this is the 3 consecutive numbers, right? So among these, there are gonna be exactly one of these 3 numbers, n minus 1 and plus 1, that's divided by 3, right? So this one, 3n plus 2, never divided by 3. And also we notice we have 24 at the denominator. So then we want this as then divided by 3. That tells us these 3 consecutive numbers, one of them must be a multiple 9. Cannot be any other number, right? So one of these must be multiple 9. So it's of course easy to see the smallest is going to be, we're going to start from 7, 8, 9 for the 3 consecutive number. So where you can see n, let's see, then we're gonna n minus 1, then n plus 1, right? So we can see this is going to be the smallest three consecutive number where n equal to 8, right? So continue, we're gonna have 8, 9, and 10. We have 9, and then we have 9, 10, and 11. So we have 10 here. Now we just find the these 3 numbers. So continue, we're going to think about next one. We're going to around 18, right? So that's going to be 18, 17, 16. We have 17 here. So then we have 18 here. We have 19, right? So 17, 18, 19. So that's going to be next 3 numbers. So do you find the pattern, right? So then this one basically is 8, 9, 10. So this is going to be 3 times 9. So then here we have 3 times 18, the sum of the 3 numbers, right? So next one we're going to have must be 27, right? 26, 27, 28. So sum going to be 3 times 27. So next one we're going to have multiple 7. That actually is 36, right? We have 35, 36, and 37. So now basically we just wanted the first 10 numbers. That's going to be 9, 10, 11. So 17, 18, 19, then 26, 27, 28, and 35. So we add this 27. This is 54. This is 81. So then we need to add 35. So add together. We have 27, 54, 81, then 35. So add together, this is 12, 7. Then we have this 10, this 197. Yes. 100, yeah, 197. The answer is B, 197. Question number 23. Each of the 5 sides of the 5 and the 5 diagonals of a regular pentagon are randomly and independently colored red or blue with equal probability. What is the probability that there will be a triangle whose vertices are among the vertices of the pentagon such that all its sides have the same color? Okay, let's draw a diagram. We have the pentagon ABCDE, and we have the diagonals ACAD, BDBE, and CACE, etc. Right? We have 5 diagonals and 5 the sides. Okay, so if you think about the look at the question, what is probability that there will be a triangle whose vertices are among the vertices of the pentagon such that all its sides have the same color? So you can see, you can imagine ABC can be the same color, blue or red, or ACD be that. So if you look at this, that's too many cases. So to count, we the better to think about opposite, right? That's complementary counting. So we're going to use the complementary probability. So instead of looking at 3 sides of a triangle in the same color, we look at no triangle has the same color, right? So then in the case, the probability actually is 1 minus p naught, right? So this means no 3 sides in the same color. All right, so to do this, we're going to focus on one of the vertices. We look at A. So we're going to think about all the sides and vertices, all the sides and the diagonals of from A colored different ways, right? So we can think about, we can color all in red, all of this in red. So if we do so, so then this must be blue, this must be blue, this must be blue, and this must be blue, right? Right? Otherwise, they're going to be have triangle this, right? So then this also must be blue, right? This also must be blue. So what do you find, right? So in this way, we got to have at least one of the triangle with 3 blue sides. So that means if we color all 4 sides for the 2 segments from A in the same color, there's no solution. No way you can get a arrangement, a configuration that give you a configuration without a triangle, in the same color, right? Okay, so this does not work. So then we're gonna look at what about color in different colors, right? Let's say we're gonna change, instead of all in the same color, in blue or red, none of they work, right? So we're gonna look at, so 3 in one color and 1 in the other color. So suppose this is gonna be blue, we have red, these 3 be red. So then again, so this must be blue, this must be blue, and this must be blue. Again, you see this is gonna be a triangle with same color. This does not work. You won't find any kind of configuration give you no triangle with the same color. This does not work, right? So we need to give one more try. So what about 2 of these? 2 in the same color or 2 in the other color? This is only ways we left. So then we can have this in red. So this in red, for example, we can let this in blue. So if we do this, you can see this must be red and this must be blue. That's for sure. Right. So actually, so this is out of 3 sides, 3 segments. We want 2 be colored, right? So we can just continue. See if we can lead a solution here. So we have one way we can think about. I want this side be red. If this side be red, then this side must be blue. If this is blue, so this is blue, so then this triangle, so this must be red. Right? So this will be red, these 2 are red, and this must be blue. We have a solution, right? So we start from here. The first one, we let this be red. Then we give exactly one solution. Okay, so let's do another one. We can let this front side here, this be blue, right? So you can see they are kind of symmetry. So we can also solve, there are going to be another solution for these, right? So overall, so if we start from two sides red, two sides blue, like here, so we're gonna get exactly two solutions, right? How many ways we have these four sides be blue, with two blue and two red? So that's actually 4 choose 2, right? And each of these give out 2. So then there are going to be 4 choose 2 times 2 ways. We can color these edges, give you no triangle with 3 sides equal with the same color, right? The probability equal to, so total will be 10 edges. That's going to be each way has 2 colors. Total probability is 2 to the power 10, right? So this one basically P now equal to 4 choose 2 times 2 over 10, 2 to the power 10. So then the final probability equal to 1 minus now P now, that's going to be 1, 4 choose 2 times 2 over 2 to the power 10, right? So let's simplify. This is going to be 1 minus, this is 6 times 2 over 2 to the power 10. So simplify, this is going to be 1 over 3 over 2 to the power 8. That's going to be 256. So find the final solution, 253 over 256. Find the answer. D is correct. Question number 24. A cube is constructed from 4 white unit cube and 4 blue unit cube. How many different ways are there to be construct the 2 by 2 by 2 cube using these smaller cubes? Two constructions are considered the same if one can be rotated to match the other, right? So here I draw the diagram. This is a 2 by 2 by 2 cube, right? So we're gonna have unit cube to do that, right? So actually, so we're gonna think about the center of each unit cube. I can simplify to this smaller cube. Remember here, so each of the vertex, each of this vertex, just the center of each cube. So we just need to think about this, just a coloring. The vertex of this is these cubes. Okay, the few possible ways to do that. The first one, basically just color the front layer all be the same color. I just use red to represent for the blue, right? For the blue color, right? The rest vertices here. So that's just showing that's going to be white, right? So now this is only one way to do that. So now we look at another case. We're going to color 3 vertices in one color, in blue, for example, right? So then you can think about the rest can be here, here, or here, or here. So total, you can see there are going to be 4 different ways. Right, okay. So then I'm going to clean this, make sure you can imagine here. So we have 4 different ways to have 3 on the one face, and then we have color the other for the back face, right? 1 point there. Right. Okay, so now we look at this one. We can color 2 points on one side of the front face, and then we're gonna do the other gonna be like this. Right. So this is gonna be one way to do that. Right. So the other ways we're gonna just see. I'm gonna color this diagonal. I color this diagonal. And then I'm going to color this diagonal, right? The back side, back face. We're going to color this. This also can have one solution. So taken all together, 4 plus 1 plus 1 give us 7. So there are going to be 7 different ways. Question number 25. A rectangle with side lengths 1 and 3. A square with side lengths 1. And a rectangle R are inscribed inside a larger square as shown. The sum of all possible value for the area of R can be written in the form of M over N, where M and N are relative prime positive integer. What is M plus N? By investigation the diagram, we can find quite a few similar right triangles. So now we starting look at these right triangle here. So in this right triangle, we have this leg we call A, this side called B, and the hypotenuse is 1, right? So we can find the same size of rectangle like triangle like here. So you can see this is gonna be B, this gonna be A, this gonna be B. We have B here, we have right triangle here with the hypotenuse 1, right? This one is also 2, A, and this is B. And for this large triangle here, that's also similar to this smaller triangle. We can easily find angle tracing. This angle and this angle congruent. We have right angle here. So now, because this hypotenuse 3, this hypotenuse 1, so easily find this is going to be 3B. So this side is going to be 3A. All right. So now we can easily set about a equation with this side is A plus 2B plus 3A equal to this side, because they are this is a big square. That's going to be 3B plus A. And easily find B equal to 3A. Go back to the original small right triangle with side A, B, and 1. So we can just solve A. So 3A squared B squared plus A squared equal to 1. Solve A equal to 1 over square root 10. And B equal to 3 over square root 10. Okay, so I'm going to clean the board and mark some lengths on this original diagram. Okay, so we find this blue right triangle has this short leg is 1 over square root 10. And this long leg is 3 over square root 10, right? So, and also we can find this long side actually is 3b, 3 times 3 square root 10, which equal to 9 over square root 10. Or simply the large square gonna have the length is 10 over square root 10. All right, so now I'm gonna draw a box around the rectangle R. So I know this is congruent to the smaller one. This is going to be 1 over square root 10. So this side actually is 3 over square root 10. So now I'm going to let you focus on this triangle, this right triangle. So this triangle actually congruent to this triangle and similar to these two right triangles. Right, and these two triangles are congruent. So we can mark this side. So this is going to be 3 over square root 10. If I call this side be x, this side be y, so I'm going to find this side actually equal to 6 over square root 10 minus x. So that's also true for this one. So this is going to be 6 over square root 10 minus x. And here I want you to point out, so if you look at this one, this triangle actually similar to the triangle, right? So if this is this side is square root 6 over 10 minus x. So this times this is going to be 1/3. 1/3 of 6 over square root 10 minus x. Okay, so now I'm going to set up our equations. Okay, the first one, we're going to find these silence. We're going to just write this down, right? So y plus 3 over square root 10 plus 1/3 of square root 10, 6 minus x, then plus 3 over square root 10, which equal to the silence, 10 over square root 10. Okay, let's simplify this a little bit. Y equal to 4 square root 10 minus 1/3 of 6 over square root 10 minus x. So which equal to 2 over square root 10 plus x over 3. Okay, so this is y. Right, so now I'm going to look at the similar triangle here. I'm going to focus this triangle and this triangle, they are similar. Okay, so we have x over 3 over square root 10 equal to y over square root of 6 over square root 10 minus x. So I'm going to plug in the y equal to 2 square root 10 plus x over 3 over 6 over square root 10 minus x. Okay, now we got a proportion equation like this. Let's simplify this a little bit before we're gonna do the cross multiplication. Okay, so the left side, we can just say reciprocal this, that's going to be x over square root 10x over 3. So which equal to, so this side, basically I'm the times the up and down, both by 3 square root 10. All right, so the bottom one, we're going to get 18 minus 3 square root 10 x. The top one, we're going to get 6 plus square root 10x. Then we do cross multiplication. So we got 18 minus 3 square root x, square root 10 times x times square root 10x equal to 3 times 6 plus square root 10x. That's 18 plus 3 square root x. So simplify further, we have 18 square root 10x minus 30x squared equal to 18 plus 3 square root 10x. Divide both sides by 3, I got 6 square root of 10x minus 10x squared equal to 6 plus square root 10x. Rewrite in the standard quadratic equation, we got 10x squared minus 5 square root 10x plus 6 equal to 0. Solve this quadratic using quadratic formula. X equal to, this is going to be 5 square root of 10 plus minus square root of 5 square root 10 squared minus 4 times 10 times 6 equal to 5 square root 10 plus minus, inside here we have square root 10. All right, so this give us either, we have two solutions. So that's going to be 5 minus, that's 4 square root 10 over 2 times 10. So which equal to 2, we can cancel, then square root 10 over 10. Or simply, I just see that's going to be 2 over square root 10. So the other one going to be 6 square root 10 over 2 times 10. So which equal to 3 square root 10 over 10. Or I write 3 over square root 10. Okay, then go back to the diagram we show here. So this x equal to 2 over square root 10. Then we can find this piece is 4 over square root 10, right? So we know this part is 3 over square root 10. This is just a 3, 4, 5 right triangle. Easy to find this length going to be 5 over square root 10, right? So if you look at here, so this is 2 square root 10. That's also 3, 4, 5 triangle. So this is the short side. This is 3. So this is going to be, this side actually is 2 over square root 10, then times 3 over 5 over 3. Right? It's easy to find the area for this triangle gonna be square root of 10, 5 over square root 10 times 2 over square root 10 times 5 over 3. So we can simply find the answer is 5 over 3, right? Okay, so this is first case. So now we look at the other case, x equal to 3 over 10. So that's going to be this figure, right? So we can see this x equal to 3 over 10. So this side going to be 3 over 10. So look at this triangle. So this is going to be 45, 45, 90 degree. So similar is this one. So these both are 45, 45, 90 degree triangle, right? So then this side will be square root 2 times 3 square root 10. Similar is this side. So the area of R, just this squared, which equal to 10 which is 2 times 9, and simplify, which is 9 over 5. Right, so taking all together, we have two possible value for the area of R. That's 5 over 3 and 9 over 5. So we want to find the sum of the possible value. So that's 5 over 3 plus 9 over 5, which is 15 over 25 plus 27 equal to 52 over 15. So this is M, this is N, M plus N equal to 67. So taking all together, the final answer for question number 25 is E. M plus N equal to 67.